I think that there are several potential liability risks, including liability for hydraulic fracturing, groundwater contamination associated with hydraulic fracturing, induced seismicity connected to wastewater injection, earthquakes that are triggered in effect by wastewater injection. Oil by rail continues to be a risk, so we have these large unit trains conveying oil around the country that has a lower flash point and higher potential for explosion. And we've got these basically a lot of assets in the oil and gas industry that are aging, and we know are problematic, but we're in a situation where we don't have a lot of appetite for investment in the infrastructure to reduce risk. Induced seismicity means that human activity led to an earthquake. And since the late 1960s, science has connected wastewater injection to earthquakes. So we've known this for about 50 years, that wastewater injection can trigger earthquakes. And the physics of it are pretty simple, actually, when you think about it. Earthquakes come from the slippage of tectonic plates. You have these plates that are lying on top of each other at pressure, and if something happens, something shifts just enough, they can slip. So what happens with wastewater injection? You have fluids that are being pumped into these geological formations that just happen to have these faults that are suitably aligned. Fluids get between the faults, these two plates, and build pressure. So over time, as the fluid accretes, they're pushing the plates apart. And once they have been unloaded enough, the slip can occur and you get an earthquake. Science around that's fairly conclusive. All of the earthquake activity in the central and eastern United States has been attributed to, all the increase in the activity has been attributed to wastewater injection over the last few years. And we're down to trying to understand the appropriate models for looking at the frequency and severity of induced seismic activity as a function of wastewater injection. So it's no longer a question in scientists' mind that does A cause B? It's now that we know A causes B, what are the right models for understanding this risk? And we worked with our partners, IRMI, to get a handle on how big of a problem is this in Oklahoma. The current scientific thinking on hydraulic fracturing, to use the contested words, are that it poses no systemic widespread risk to groundwater. Now, those words appeared in the EPA's study of risks associated with hydraulic fracturing. The EPA's Science Committee has, since that time, taken a look at the report and tried to dial back that conclusion to some extent, because even though we don't see lots and lots of instances of groundwater contamination associated with fracked wells, we nonetheless have several incidents that were bad enough, create a lot of attention, create a lot of problems for people that were serious, that are ongoing. And we have this component of the risk that is latent. We don't understand the subsurface of the earth as well as we would like to. And there's concern about how these fluids might migrate over time. We don't monitor them very well. And we have a lot to learn about how the shale formations interact with the fluids injected. Are they taken up? Do they ultimately migrate out? And what would the timeline be for the connection between those formations and sources of groundwater?